Hello and welcome to this video in the R Analytics course. In this video, we will be looking at the mechanism of looping in R. Looping is a process which is used when we want the same task to be repeated more than one time, such as a particular function or calculation to be used multiple times. We can specify the value of the variables over which the loop should run, say for values of variable I going from 1 to 5, and we can also specify the tasks that need to be performed each time the variable takes these values. Hence, whenever the variable I will take values 1, 2, 3, 4 or 5, the specified tasks will be performed. This mechanism will help us in reducing the manual effort that goes into a particular task and do the job at hand more efficiently. There are mainly three kinds of loops in R. These are similar to the loops available in other programming languages such as VBA and hence may appear familiar. Let us look at what these are. Number 1. For loop or for each loop. This loop performs a specified task for each value of the specified variable. Say we have a vector. We want that for each of the elements of the vector, which are greater than 100, we wish to add these elements and obtain their total. If we do not use a loop, we will need to first search or filter the values which are greater than 100 and then obtain their sum. So essentially, we look for a value greater than 100 and then find another value greater than 100 and sum these. Again, we will search for another value greater than 100 and then add it to the previous sum. Hence, we are repeating the same task multiple times, which may become cumbersome. Instead of doing this, we can use a for each loop to perform the sum function for each value in the vector which is greater than 100. Second type is the while loop. This loop is used when we are not aware of how many times the loop will be run. Say, we have an investor who deposits 5,000 each month and earns a compounded rate of interest of 8% per annum on that deposit. He wishes to withdraw the money when the value of his investment becomes 5 lakh. Here, we are not aware of how many iterations it will take for the deposit value to become 5 lakhs. Hence, we would want our loop to run while the value of the deposit is less than 5 lakhs. That is, start with 5,000 and compound this figure at 8% per annum. Do this while its value is less than 5 lakhs and stop it when it becomes 5 lakhs. It first checks the condition specified by the user and then, while statement is true, it keeps performing the tasks specified by the user. The third type is the repeat loop. This loop is equivalent to the do until loop in other programming languages. Here, we first perform the statement and then specify the condition. For example, say the variable x takes values 1, 2, 3 and so on. We wish to increment the value of x by 1. That is, we want the value of x to be x plus 1. Now this is the task to be performed. However, we want the incremented value of x only till x reaches the value 10. This is the condition. Hence, the loop will first perform the task and then check at the end if after adding the value of x is less than or equal to 10. If it is, then it will add the next number. Else the loop will break. This is different from the while loop where first the condition is checked and then the task is performed. Let us now see the operation of these loops in the R software. We will start with the for loop. Say, we start with a vector x which has elements 2, 5, 1, 7, 9, 3, and 6. We want to know how many elements of x are greater than or equal to 5. Let us now take a counting variable n whose value starts from 0. This variable will count over the elements of vector x to determine which are greater than or equal to 5. Now let us write the for loop command. Write for, inside brackets write y in x, close the brackets. Here, y is the temporary variable which runs over each element of vector x. Now we write the condition, that is, for which y's in vector x do we want the task to be performed. Inside curly brackets, we will write the condition, that is, if y is greater than equal to 5, take the counting variable n and add 1 to it, and move to the next variable. If the element y is not greater than or equal to 5, then let the value of n remain the same. So n will start with the value 0 as we have specified. Then for the first element in x, its value will remain 0 since 2 is not greater than or equal to 5. Then the loop moves to the next y, which is 5. Here y is greater or equal to 5. Hence 1 gets added to n and its value becomes 1. Then it moves to the next element, which is 1, which is not greater than or equal to 5. Hence the value of n remains 1. Then the loop moves to the element 7 and the value of n becomes 2. Then it moves to 9 and the value of n becomes 3. Then it moves to 3 and the value of n will not get incremented and remain 3. Finally, it will become 4 when the loop moves to the element 6. Once the loop has run for all the values in y, we want the final value of n to be printed. That is, print the number of elements of x which are greater than or equal to 5. Write colon to indicate the start of the next task to be performed and write print n. We see that we get the value 4. Let us look at another example of the for loop. This time we have a vector x which has both positive and negative elements. We wish to obtain the sum of only those elements which are positive. Let us take a counting variable n which starts from the value 0 as in the previous example. Otherwise, here since we will be calculating the sum, we can also call the variable s for sum. Its initial value is 0. Now write for, inside brackets write z in x, close the brackets. Here z is the temporary variable which runs over each element of vector x. Now we write the condition, that is, for which z's in vector x do we want the task to be performed. Inside curly brackets, we will write the condition, that is, if z is greater than 0, take the sum variable s and add z to it, and then move to the next variable. If the element z is not greater than 0, then let the value of s remain the same. Hence, the loop starts from the first element 12, and since this is positive, it adds this value to the value of s, which is till now 0. Then it runs over -10 and -5 and does nothing. Then the loop moves to z is equal to 3 and adds this to the existing value of s, which is 12. Hence, the value of s becomes 15. This way, the loop runs over all the elements of vector x and checks each element for its value. Once the loop has run over all the values, we want the value of s to be printed, that is, the sum to be printed. We see that we obtain the value 37. In another example, let us look at another variable x, which stores the values from 1 to 20. Now write for, inside brackets write b in x, close the brackets. Here, b is the temporary variable which runs over each element of vector x. Now we write the condition, that is, for which b's in vector x do we want the task to be performed. Inside curly brackets, we will mention the condition, that is, if b is lesser than 10, then go to the next element in x. If the element b is not lesser than 10, that is, it is greater than or equal to 10, then print the value of b. Remember to write the next statement within curly brackets inside the main curly brackets. The next statement is used to skip a particular value of a variable within a given set of values. Here, we wanted to keep skipping the values of x till these were lesser than 10. On pressing enter, we saw that we obtained all the values of x which are greater than or equal to 10 as required. Similar to the next statement, we have the break statement, which is very helpful to use within a loop. Let us take the same example, x taking values from 1 to 20. For b in x, if b is greater than or equal to 10, in curly brackets write break. Print the value of b. On pressing enter, we see that it generates all the values of x which are lesser than 10. Hence, the break statement can be used to break the loop at a particular stage or step within the condition. The specified task in the statement will only be performed till the loop gets broken. We can keep in mind that next and break are opposites of each other, where next is used when we want to skip a few values of the variables to perform the task, and break is used to perform the task only on a few variables and not the rest. Let us now move to the next loop, the while loop. Let us take the example we mentioned earlier. Say we have an individual who can save 5,000 rupees per month and he wishes to accumulate 5 lakh rupees to buy a specific car. Obviously, the money he invests will earn some pre-specified rate of interest. He wishes to find out in how many months will the value of his savings become 5 lakhs. We can use the while loop for this. Let us see how. Start with a variable amount equal to 5,000. Another variable rate equal to 0.08, that is the rate of interest 8% per month. The initial value of the variable month will be 0 and the initial value of the total investment at the start of the first month is 0. The syntax of the while loop is while, within brackets write the condition to be tested, and then inside curly brackets write the statement to be executed while the condition is true. Let us specify our condition. We want the money invested to keep getting accumulated till the value of the total investment becomes 5 lakhs. Write total less than 5 lakhs. Let us now write the statement. We want to add in this variable total the initial value of the variable amount, that is the first tranche of saving. Write total is equal to total plus amount. Put a semicolon to start a new statement. Now we will calculate the interest. Take a new variable interest is equal to total multiplied by rate. Then we will add this interest in the variable total to get the value of the total investment after the interest is added for the first month. Finally, we want this to be done for each month till the total investment becomes 5 lakhs. Hence, let us keep incrementing the value of the variable month by writing month is equal to month plus 1. Finally, put a semicolon to write the last statement, that is, print month and print total. On pressing enter, we get an error stating that the object interest not defined. This is because we have not defined the variable interest along with the other variables before using it in our while loop. Let us specify all the variables again, amount, rate, month and interest, and run the same while loop again. It prompts us to correct the spelling of the variable interest. Be sure to not make such small but critical errors. Now if we press enter, we get all the months and the corresponding total values at the start of each month. At the beginning of the first month, deposited 5,000. At the start of the second month, he deposited another 5,000 and earned 8% interest on the total investment for the investment to become 10,800. And so on and so forth till the 28th month where it exceeded 5 lakhs. Hence, he will need to deposit the money for 28 months in order to accumulate 5 lakhs if he earns 8% per month on his savings. However, you know that in the real world, such a rate of return is not achievable. Let us now assume this 8% to be annual rate of return. Now if we define all the variables again, month equal to 1, total equal to 0, interest equal to 0, and in our while loop, when we are calculating the variable interest by multiplying the total by rate, we can divide the rate by 12 to indicate that the 0.08 divided by 12 is the monthly rate of interest earned. Now if we press enter, we see that finally in the 76th month, the investment crosses 5 lakh rupees. That is, the individual will have to save for at least 70 months or almost 6 years before he can buy the car he wants. This was the while loop. Let us now take a look at the repeat loop. This is the easiest to understand and use. We have x is equal to 1. We use the repeat loop by writing repeat, and in the curly brackets, we first write the task to be performed. We write print x semicolon, increment the value of x each time the loop repeats. Now, we specify the condition for how many times the loop will be repeated. Semicolon. If x is equal to 10, then break the code. Hence, we want the increment function to be repeated till x reaches the value 10 and then to break the loop, that is, to not repeat the loop after that. When we press enter, we see that it prints all the values the variable x can take on incrementing till it becomes equal to 10. That is, the loop terminates right when x becomes equal to 10, and hence only values till x equal to 9 are printed. This was an extremely simple repeat loop example. In subsequent videos, we will learn how we can use these loops more extensively to perform more complex tasks. For now, we hope you are well acquainted with the syntax of the commands for each of these loops. This is it for this video. Thank you.